Hi friends, so here in this problem sin alpha is given which is 12 by 13, then cos beta is given 3 by 5, and it is also said that alpha lies in second quadrant, that is between 90 degree to 180 degree, and beta lies in the first quadrant, that is between 0 to 90 degree, and we have to find out the value of cos of alpha plus beta. So guys, let's find out the value. So to get the value of cos of alpha plus beta, I will use the identity, that is cos of alpha cos of beta minus sin of alpha sin of beta. So to get the value of cos of alpha plus beta, we should know these four trigonometric functions. So out of this, sin alpha is given as 12 by 13, cos beta is given, but still cos alpha and sin beta are the unknowns. So first of all, let's find out the value of cos alpha and sin beta, and then let's substitute these four values here. So for that, I'll give this as equation number 1, and by substituting the four values, we can get the value of cos of alpha plus beta. So let's start. So to get the value of cos alpha, we will find this value from sin alpha, and for that we will use the identity. So we know that cos of alpha, or I'll say cos square alpha, is 1 minus sin square alpha. Now this is nothing but 1 minus sin alpha the whole square, and the value of sin alpha is 12 by 13. So this will be 1 minus 144 by 169, and this will give us 169 minus 144 upon 169, and this is nothing but 25 upon 169 as the value of cos square alpha. Now to get the value of cos alpha as required in result 1, we have to take square root on both sides. So taking square root on both sides, we will get cos alpha on LHS, whereas on right hand side we will get two values. So one value will be positive and other will be negative 5 by 13. So it means we got two values of cos alpha. Now the question comes is which value we should accept. So if you'll see the alpha, then alpha lies in second quadrant, that is between pi by 2 to pi, and we have seen in the quadrant system that in the second quadrant the sine and cosec are positive. So here I'll write alpha lies in, and therefore cos of alpha is negative in second quadrant. So since cos alpha always gives us negative value in second quadrant, here we will accept the negative value as the value of cos alpha. So therefore the value of cos alpha would be minus 5 by 13. So we got the value of cos alpha. Now let's find out the value of sin beta from cos beta. So again I will use the same identity. So therefore now I'll say sin square beta is equal to 1 minus cos square beta. So which is equal to 1 minus cos beta the whole square. Now what is the value of cos beta? So cos beta is 3 by 5. So here we will get 3 by 5 the whole square, which is 1 minus 9 upon 25, and which is equal to 25 minus 9 upon 25, and which is equal to 16 upon 25. So this is the value of sine square beta. Now to get the value of sine beta, we have to take square root on both sides. So here we will get, therefore the sine beta is equal to plus or minus 4 by 5. It means we are getting two values of sine beta, one is positive and one is negative. Now again the question comes, which value we should accept. So if you will see here, then beta lies in first quadrant, that is between 0 to pi by 2, and in first quadrant all trigonometric functions are positive. So here this sine beta will be positive. So we will accept the value plus 4 by 5. So here I will say, here beta lies in first quadrant, and therefore sine of beta is positive in first quadrant. So therefore the value of sine beta is equals to 4 by 5. So we got the value of sine beta as well as we got the value of cos alpha. Now it's time to find out the value of cos of alpha plus beta. So let's substitute the four values. So I want value of cos alpha, which is minus 5 by 13. So we will get, therefore cos of alpha plus beta is equal to cos alpha, that is minus 5 by 13, then cos beta, which is given in the question, that is 3 by 5, minus sine alpha, which is given in the question, which is 12 by 13, and sine beta, which is 4 by 5. So let's find out the value. So this will become 13 5s are, that is 65, and this is minus 15, minus again here we will get 65, and 12 4s are, that is 48. Then we'll sum it up. So here we will get 65 as a common denominator, and if we will add minus 15 with minus 48, then we will get minus of 63. So the value of cos of alpha plus beta is minus 63 upon 65. Thank you.